The height of a moving object h of t is modeled by this equation, that is h of t equals at squared plus bt plus c. So this is the model to represent the height, and the height of the object at different time intervals is given in the table. That is, at time t equal to 2 seconds, the moving object is at a height of 34 meters. And likewise, at 5 seconds, 38 meters, and 7 seconds, it is at 27 meters. And first, we have to show that 4a plus 2b plus c equals 34. So let's see how to show this equality. So to answer part A, all that we have to do is we have to plug in this value of t equal to 2 and h of t equal to 34 into this model. So let me do that. I plug in h of t equal to 34. When I do that, I get 34 on the left side. And for all the values of t, I plug in t. I'm sorry, I plug in t equal to 2. So therefore, a times of 2 square plus b times of 2 plus c. So this gives 34 equal to square is 4. 4 times of a is 4a plus 2 times of b is 2b plus c. So with this can be rewritten in by transforming or rewriting the variables on the left side. So I can write down this as 4a plus 2b plus c equals 34. So let's call this equation as number 1, and we have just shown that 4a plus 2b plus c equal to 34. So the first part we have done. We will now do the part B. In this, we have to determine two more equations involving a, b, and c. So we can plug in the second result, that is the at t equal to 5 seconds, the height equal to 38. So I'm going to plug in height equal to 38 and t equal to 5 into this equation, and when I do that, I have 38 on the left side, and for all the values of t I'm going to plug in 5. So therefore this becomes a times of 5 squared plus b times of 5 plus c. Now I can simplify this. So this is equal to 38 equals 5 square is 25. So 25 times a is 25a, and then 5 times b is 5b, and then we have this c. So this can be rewritten as by having the variables on the left side. So 25a plus 5b plus c equal to 38. So this is another equation. Let's call this as equation number 2. Now let's plug in the last value, that is t equal to 7 seconds, the height equal to 27 meters. So I'm going to plug in h equal to 27, h of t equal to 27, and t equal to 7. So when I do that, I replace t by 7. So it becomes 7 square plus b times of 7 plus c. So this implies 27 equals 7 square is 49. So it is 49a and 7b plus c. So this can be rewritten as 49a plus 7b plus c equals 27. Let's say this is equation number 3. So uh, we have written the two more equations for a, b, and c. Equation number 2 and equation number 3 are the other two equations. We now do the part C, which is we have to solve the equations. So first, let me take the equation number 1 and just write down as it is, that is 4a plus 2b plus c equals 34. And let me also write down the second equation as it is, so which is 25a plus 5b plus c equals 38. To solve the equations, I'm going to use the method of elimination. Here I'm going to eliminate the c variable first and then the b variable, so that I can find the value of a variable first, and then I do the back substitution for a, b, and c, so we can solve the equation. So that's why I have written these two equations as it is. Let me eliminate the c from these two equations. So I'm going to subtract 1 minus 2. I'm going to do this. So when I do that, I can change the sign of the uh, bottom equation. So I put like this. So therefore this plus positive c and negative c will get cancelled, and 4a minus 25a is negative 21a, and 2b minus 3b 5b is negative 3b. This is equal to 34 minus 38 is negative 4. As you can see that every term has negative both on the left side as well as the right side. So we can divide all the terms by negative 1 just to remove the negativity. So this becomes 21a plus 3b equals 4. So let's say this is equation number 4. Now I use the equation 2 and 3 and eliminate the c from these two equations. So let me copy the equation number 2. So equation number 2 is 25a plus 5b plus c equals 38. And equation number 3 is 49a plus 7b plus c equals 24. So once again I do the subtraction, that is I do 2 minus 3, equation number 2 minus 3. If I have to do like this, I have to change the sign of the equation number 3. So I completely change the sign of all the numbers. Now I can do the subtraction, that is plus c minus c will become 0. 25a minus 49a is minus of 24a. 5b minus 7b is minus 2b, and 38 minus 24 is 14. Let's call this equation as equation number 5. Now we can see that from equations 4 and 5, the variable c is eliminated. So now we are now going to eliminate the b variable from these two equations, that is from equation number 4 and 5. So for that we need to have a common factor for 3, that is the coefficient of b has to be the same in both equations. So I'm going to consider the equation 4 and multiply by 2. So when I do that, I get 21 times of 2 is 42a, plus 3b times of 2 is 6b, and 4 times 2 is 8. And for equation 5, I'm going to multiply by 3. So when I do that, negative 24 times of 3 is negative 72a, and minus 2b times of 3 is negative 6b. This is equal to 14 times of 3 is 42. Now we can see that we have positive 6b and negative 6b. So we just have to add here. So when we add, we don't have to change the sign. So you can simply cancel these two terms. Now 42a minus 72a is negative 30a. And this is equal to, we are adding here. So 42 plus 8 is 50. So now we can determine the value of a. If we divide both sides by 30. So I do that 50 by minus 30. This is equal to negative 5 by 3. So we get the value of a equal to 5 by 3. Now let me substitute the value of a into one of the equation, that is I can substitute either in equation number 4 or in equation number 5. So let me do it in equation number 4. So when I do that, I get 21 times of a is negative 5 by 3. This is negative 5 by 3 plus 3 times of b equals 4. I can do some cancellation here. 21 goes 3 times as 7 times. So 7 times of negative 5 is negative 35 plus 3b equals 4. We add 35 on both sides. We get 4 plus 35 is 39. We divide both sides by 3. So we get the value of b equals 39 by 3 is 13. So the value of b equals 13. And finally, we determine the value of C by plugging the values of A and B into equation number 1. We could plug in into equation number 2 or 3 as well. So let me do it in equation number 1. Probably that seems to be simpler compared to equation number 2 and 3. So I'm plugging into equation number 1. So we have 4 times of A is negative 5 by 3 plus 2b, that is 2 times of b is 13, plus c equal to 34. So let me simplify this. This is 4 times of minus 5 is negative 20 by 3, plus 2 times of 13 is 26, plus c equals 34. So first let me subtract this 26 on both sides. So negative 20 by 3 plus c equals 34 minus 26. So this is going to be 8. So I put 8 here. We just clear this off. Now I have to add 20 by 3 to both sides. So this will become 8 plus 20 by 3. And this is equal to, I should have a common denominator. So I multiply and divide the 8 by 3. So therefore it becomes 8 times of 3 by 3 plus 20 by 3. This is equal to 24 by 3 plus 20 by 3. So it's basically gives C equals 24 plus 20 is 44 by 3. So therefore the value of C equal to 44 by 3. And this means we have solved the equation. That is we have answered the part C. Part B and part A we have already answered. So let's now do the part D. So for doing the part D we have to form the model with the values. So let me plug in the values of A, B and C into the model h of t. So we can write down the h of t equals A is negative 5 by 3 t square, plus B is 13, so it becomes 13t, plus C, which is 44 by 3. So this is the model for the height of the object. We have to determine when the height of the object is 0. So basically we are finding at what time the height becomes 0. So therefore I can plug in h of t equal to 0 into this model and determine the height. Determine the time. So I put 0 for h of t and then write down all the terms on the right side as it is, 13t plus 44 by 3. So this is basically a quadratic equation where we have to find the values of t. That is basically we have to find the roots of this quadratic equation. So first let me multiply all the terms by 3 so that I can remove the fraction or the denominator. So when I do that I get 0 equals minus 5t squared plus 13 times of 3 is 39t plus 44. So this can be rewritten in the form as negative 5t squared plus 39t plus 44 equal to 0. So to solve this equation, we can use the formula method. So let's identify the values of a, b and c in this quadratic equation. So this is a equal to negative 5 and b equal to 39 and c equal to 44. So these a, b and c's are entirely different from the actual equation. These are the parts of the coefficients of the constant x squared term, x term and the constant term in the general form of a quadratic equation. So these are all for quadratic equation. So the formula is, let's write the formula of quadratic equation to find the roots. X equal to minus b plus minus square root of b squared minus 4ac over 2a. So this is the formula which we are going to use to find the roots of the quadratic equation. So here I write down t because this is a quadratic equation in t variable. So I put t equal to negative b, which is you can substitute the value of negative b. So I put negative and b equals 39. So it becomes minus 39 plus minus the square root of b square, which is 39 square minus 4 times of a is negative 5 and then c is 44 over 2 times of a is minus 5. Let's continue. So we can simplify this. So therefore this becomes negative 39 plus minus. Now we can use the calculator to determine these values. 39 square is 1521, that is 1521. Now we have two negatives here, that is negative 4 and negative 5. So this becomes positive, and 4 times 5 and multiplied by 44. So it's basically 20 times of 44. I'm finding in the calculator, which is 880, divided by 2 times of negative 5 in the denominator is negative 10. So this simplifies to 1521 plus 880 is 2401 divided by negative 10. Now let's find the square root of 2401. So this is equal to 49. So therefore this becomes negative 39 plus minus 49 by 10. So therefore there are two values of t, that is t equals minus 39 plus 49 by 10, comma minus 39 minus 49 by 10. So these are the two roots. Let's see if both are valid or one of them is not valid. Negative 39 plus the denominator is negative 10. I'm sorry about it. Negative 39 plus 49 is positive 10 divided by negative 10, and this is negative 39. Negative 49 is negative 88 over 10. So we can see that this reduces to negative 1 and this reduced to minus 8.8 because we are dividing by uh, minus 10. So therefore this becomes a positive 8.8. It's not negative, it is positive. So therefore we are getting the values of t equal to either negative 1 or 8.8. Since t cannot be negative, we ignore this value and we consider only the value of t as 8.8 second. So therefore at t equal to 8.8 second, the height of the object is 0. This answers the question in part D. Now let's answer the last part of this question, that is in part E. We have to determine the maximum height of the object. So as this h of t is modeled in quadratic function, we know that from the quadratic function properties, the maximum value of a quadratic function appears at the vertex of the quadratic function. The vertex is given by f of minus b by 2a. Suppose if the function is f of x equal to ax squared plus bx plus c. So for this quadratic equation, the maximum value occurs at f of minus b by 2a. So we will find the maximum value for our quadratic model, that is h of t equals minus 5 by 3 t squared plus 13t plus 44 by 3. So first let's find out what is minus b by 2a. So let's identify the a. This is a, and this is b, which is the number in front of the t, and this value is c. We just need only the negative b by 2a. So let's do this negative b by 2a. This is equal to, since b is 13, this is negative 13 divided by 2 times of a is negative 5 by 3. So I put like this. So this can be written as we have two negatives in the numerator and denominator. We can simply cancel them. So this can be written as 13 times of, 13 divided by 2 times of 5, and then this 3 will get multiplied with the numerator. So therefore it becomes 13 times of 3 by 5. So this is equal to 13 is 39 divided by 10, and this is equal to 3.9. So what we have found out is just the value of t when the object reaches the maximum height. So to determine the maximum height, we have to find this h of minus b by 2a. That is, we have to find h of, we just found minus b by 2a is 3.9. So basically we have to find h of 3.9, and this means we have to substitute t as 3.9 into the h of t model. So that is into this equation. So let me do that. So this is going to be minus pi by 3. In place of t, I'm replacing it as 3.9. So therefore this becomes minus pi by 3 times of 3.9 square plus 13 times of 3.9 plus 44 by 3. We can plug this into the calculator, and when we do that we get approximately 40.01 meters. So this is the maximum height reached by the object. So we have answered the question in part E.